Hey, Algebra 2, we're going to get 4.3 done. We're going to multiply and divide some rational expressions. So there's a lot of factoring involved in this lesson, so we'll do a little factoring practice to get started here. All right, so recall when I'm factoring, right, I'm trying to find the greatest common factor of all of the terms of the expression. So in this particular term, 3x minus 18, I see that both 3x and negative 18 are divisible by 3. So I go ahead and I take the 3 out of there. I like to pull it out into the front. And then I have some parentheses here. What goes in my parentheses is essentially what I need to multiply 3 by to get to 3x and to get to negative 18, right? So 3 times what is 3x? Well, just x, right? So that's why the x goes there. And 3 times what is negative 18? It's negative 6. And then you can go back and check it, right? So I like to say, okay, 3 times x gives me the 3x, and the 3 times the negative 6 gives me the negative 18. So we're good. It's factored. Yes. All right. For number 2, this has 2 terms, and the greatest common factor of both terms is 4. And then what do I need to multiply 4 by to get to 4x? Well, that's x. And what do I need to multiply 12 by, or 4 by to get to 12? That's 3. And then it's been factored. I multiply it out in my head to make sure that it's right. 4 times x is 4x. 4 times 3 is 12. We got it. This one's a little different, right? As I don't have any numbers here. Oops. I don't know why we advanced the screen, but we did. Okay. There we go. Deleted it. That's not good. I'll have to move that button. All right. So these don't have any numbers. They only have x's, right? Well, x divides x and x divides x squared. So I can pull an x out as my greatest common factor. And what do I need to multiply x by to get x squared? Well, just x. And what do I need to multiply x by to get to x? Well, 1, because right when I multiply by 1, it doesn't change anything. And so that has been factored. All right, this last one is one that you're going to encounter quite a bit in this lesson. And this is something that's called difference of squares. Now, there are 2 different ways to look at it. One way, you can use your x if you recognize that there is a 0x in there, right? And then if I was going to use my x from this factoring method, I put the negative 16 on the top and the 0 on the bottom. And I need to think of 2 numbers such that when I multiply them, I get negative 16. And when I add them, I get 0. And the 2 numbers I like are 4 and negative 4. So that means that this factors as x plus 4 and x minus 4. Now, there's another way to do this. So this is a special type of binomial called difference of squares. And it's in the form a squared plus b squared. My bad. How about minus b squared? All right, well, it's a fact that this actually factors out to be a plus b, a minus b, right? And in this case, if you were looking at x squared minus 16, that's x squared minus 4 squared, right? So then a is x and b is 4. And that's why we're able to plug that in, right? Where the a goes right there and the b goes right there and so on, right? As you go through it. So there's a shorter way to do it by realizing that it's difference of squares. And you can do it either way. I'm going to use the idea that it's difference of squares throughout the lesson. All right. So let's go ahead and simplify this rational expression. So the first thing I'm going to do is I'm going to factor. So we have already determined difference of squares. So two numbers such that when I multiply them, I get -4, but when I add them, I get 0. Those numbers are going to be 4. Sorry, my bad. 2 and -2. On the bottom, I need to factor this, and you can get out your x if you like, right? You know it's going to end up like this. If we get out our x, on the top, I put -10. On the bottom, I put 3. Two numbers such that when I multiply them, I get -10, and when I add them, I get +3. I like 5 and -2. So that means I'll put a 5 here and a -2 here. I'm going to go ahead and rewrite this expression down here, not doing anything to change it, but just copying. And isn't it the case that x minus 2 over x minus 2 is 1, right? Anything where the numerator and the denominator are exactly the same is just 1, right? And so for that reason, these cancel out, because 1 time anything, it doesn't change the expression. So what I'm left with is x plus 2 divided by x plus 5. All right, let's do another one. So, first thing I see when I look at my numerator and my denominator actually is that they all have x as a factor. So they all have a greatest common factor of x. So I'm going to pull that out first. I'm going to factor it out, if you will. And you will. Just kidding. I mean, but you will. All right. When I factor that x out of my numerator and denominator, I have this expression. I have a trinomial on the top that can be factored and a trinomial on the bottom that can be factored. So we will factor each one. All right, for my numerator, I need to think of two numbers such that when I multiply them, I get -24, but when I add them, I get -5. I like 8 and 3. And because this -5 is, because the 5x is negative, right? It's a -5, then this means that that -8 needs to be, sorry, that 8 needs to be negative, right? So that when I add them, I get a -5. When I add -8 and +3, I get that -5. We're going to do the same thing with this bottom trinomial, x squared plus x minus 72. I need to think of two numbers such that when I multiply them, I get 72, but when I add them, I get +1. I like 9 and 8. And the 9 has to be positive because 9 minus 8 will give me this +1, which is the coefficient of x there. All right, the next thing I'm going to do is, and now rather than rewriting it, I want to look at it this way, right? If I have a matching quantity in my numerator and in my denominator, if I have a matching quantity, ooh, that wasn't a good thing to do, in my numerator and my denominator, well, I am able to just cancel those guys out. So what I have left, oh, I also have an x over x as well, which is 1. And so what I'm left with is x plus 3 over x plus 9. Come on, plus. There we go. Sort of. Kind of. There we go. All right, let's do another one. This is so fun. Okay. I don't know what's going on with all of this. I guess I should have fixed it before I recorded a video, but I'm not going to follow these steps. I like to look at this in a different way. First thing I do is I straight up just multiply this out. So I multiply my numerator and my denominator as you would when you're multiplying fractions, right? You just multiply your numerator straight across and your denominator straight across. Easy for you to say. All right, 2 times 3 is 6. X times x squared is x cubed. And this y has no friends in the numerator. Maybe it'll make friends in the denominator. All right, and then the 4, there's nothing really, or we're multiplying by 1 or nothing if you like. The y has nothing to multiply in the denominator, but z times z, that's a thing. We're going to call it z squared. All right, at this point in time, you might see that you have a y over y, and you can cancel those. I'm going to make this a little more complicated, and I'm going to break it up just so we can kind of see what's going on. What's going on? We have this y over y and 1 over z squared. All right, these two expressions that I just wrote on either side of that equal sign are equivalent, right? I just kind of broke it up so I can see all its little parts, right? I have a number part, I have my part that has x's, my part that has y's, and my part that has z's. And it just helps me to look at this thing, right? First of all, I want to simplify this fraction 6/4. That turns out to be 3/2 when I simplify, right? The x cubed, can't really do anything with that guy. Y over y, though, that's 1. And 1 over z, and I swear that's a 2, over z squared. Now I'm going to put it all together. 3 times x cubed times 1 is 3x cubed. And 2 times 1 times z squared is 2z squared. And we're done. These are a little bit complicated. I really like breaking them up first. When I'm doing this in my head, that's what my brain is doing. It's breaking it up and then putting it back together. All right. And as you get better at that, I think you might be doing that as well. So now we are going to follow these steps. We're going to factor our numerator and our denominator. I'll write it all as one expression, and then we'll start canceling. So the first thing we're going to do, there's no factoring that can be done to this quantity x plus 2 divided by x minus 2. However, I can factor both my numerator and my denominator in this next expression that we have on the right-hand side of our multiplication sign. This x squared minus 4 is difference of squares, and we recognize that that must be x minus 2 times x plus 2. For the trinomial that I have in my denominator, this x squared plus x minus 2, I'm going to think to myself, what two numbers multiply to get, or their product is -2, and their sum, or when I add them together, I get +1. Well, I like 2 and -1. All right, now I'm going to write this all just as one expression. I'm just going to put it all together. It's not a necessary step, but I think it's nice to see the algebra, to see that this is all one quantity, because we are multiplying, right? If I'm multiplying this times that, these are essentially the same thing, these two numerators. Now I'm going to find things that match. I got an x plus 2 in my numerator. I've got an x plus 2 in my denominator. Those can go away. And I think that's all that I'm able to cancel. And so I'll rewrite this as x minus 2 times x plus 2 divided by x minus 1. And we're done. I can't factor that anymore. I can multiply it back out and have something different. But the expression that I would have when I multiply out that numerator is really not as useful as what I have right here. Moving along. We're going to do another one where we're multiplying, but we have to do a little bit of factoring first. Well, it might be a lot. Depends on your perspective, I guess. All right, so the numerator. For my second expression, I need to think of two numbers such that when I multiply them, I get +4, and when I add them, I get +4. Well, that's got to be 2. And 2, both of them positive. And next, I need to factor this. It's difference of squares again. So the square root of 9 3. And there you have it. Now, rather than grouping it all as one, because I think we saw it works, I can just pick out what matches in my numerator and my denominator. So I have a y plus 3 in my numerator. I have a y plus 3 in my denominator. I have a y plus 2 in my numerator. I have a y plus 2 in my denominator. And so all I'm left with, when it's all said and done, is y plus 2 divided by y plus 3. All right, so now we're dividing. So it just adds one more step. Remember back in the day when you were doing fractions, maybe your teacher said copy dot flip. I just say flip and multiply. But I mean, just a small example, right? If I was to do 1/2 divided by 2/3, right? What would I do? I would go 1/2 times, and then I would flip that second term. And now I'm going to just multiply straight across. So that becomes 3/4. So we're basically doing the same thing, but we have a bunch of variables and stuff. So let's go ahead and do that. So the first expression, or the first quantity in this expression, stays the same. And now instead of dividing, I'm multiplying. And I'm going to go ahead and flip that second rational expression that I have in this dealio. All right. Now I'm going to go ahead and multiply straight across, just like I did in this example. 4 times 25 is 100. And the x has nothing to go with, and we have a y squared here. 5 times 20, also 100. And y has nothing to multiply, and neither does this x squared. Okay, I need a little more room, because I'm going to go ahead and break this thing up into 100 over 100 times x over x. Whoa. I left. No, we got it. We're good. Okay, sorry. X over x squared. There we go. I knew there was something going on there. All right. And then right here we have a y squared over y. All right. When we simplify this thing, 100 over 100 is 1. So we'll just cancel that out. X over x squared turns out to be 1 over x. Okay. If you were thinking that's weird, remember x squared is x times x, right? So those guys cancel, and that's why what I'm left with is 1 over x. All right. For the same reason, y squared divided by y is just going to be y over 1. And so my answer is y over x. These get slightly more complicated as we go. And there you go. So let's go ahead and change that division sign to a multiplication sign and flip that second quantity in the expression. We'll do that first. So this becomes y squared minus 16 divided by y squared minus 10y plus 25 times, and this is the thing that we're changing now. I am putting my denominator in the numerator and the numerator in the denominator. And there it is. I think that now I'm going to have to come down here. And let's go ahead and factor that numerator. So we're coming down over here. All right. I see a difference of squares in this numerator, so this means that this must be y plus 4 times y minus 4. And then in my denominator, I need to think of two numbers such that when I multiply them, I get 25. But when I add them, when I multiply them, I get negative 25. And when I add them, I get, when I multiply them, I get positive 25. When I add them, I get negative 10. I like negative 5 and negative 5. I think that'll do the trick. All right, let's go ahead and factor the numerator over here in this expression on the right-hand side of my multiplication sign. I need to think of two numbers such that when I multiply them, I get negative 10, but when I add them, I get negative 3. I like 5 and 2. And the 5's got to be negative in order to get this, negative in front of this 3. And now 3y minus 12, it looks like the greatest common factor of 3y and negative 12 is just 3. So I'm going to factor a 3 out of that expression. And there you have it. Now I'm at the point where I can figure out what is matching in my numerator and my denominator. For instance, I see that I have a y minus 4 in my numerator and 1 in my denominator. I see that I have a y minus 5 in my numerator, and I also have a y minus 5 in my denominator. And I don't see any other quantities that can be canceled out. So what I have left, the 3 is still there. I'm going to put it out front. And we're done. And that concludes our fun for today. Thanks, guys. Hope you're having a great day. And if you're not, hope it gets better.